Hello students, welcome to my channel eScience. In the last session, we have discussed about the quantum numbers, right? So there we discussed about quantum numbers are the address of the electrons we have said, right? Then how to find the electrons and how to write the electronic configurations, how to mention the address of the electron. So that things we are going to discuss now, okay? So for writing the electronic configurations, we are following a method that is NLX method. We are following a method NLX method. What we are following? NLX method, right? So once you see that NLX method, NLX, that means N is what here? Principal quantum number. As we know, N is principal quantum number, and that is giving the information about the orbit. That giving the information about orbit. That is which orbit, in which orbit the electron is there, right? And right. L means what? It is the angular momentum quantum number, right? Angular momentum quantum number, and it is giving the information about orbital. That is the particular electron is present in which orbital, in which orbit, again in which orbital, right? So that is NL. And X is the number of electron, that is in that particular orbital how many electrons are there. As already we know, in the orbital suborbitals are there, in the suborbitals electrons will be there, right? How many electrons are there? 1 is there, 2 is there, 6 is there, 10 is there. So that we will discuss, okay? So that is we are following a method NLX method. What we are calling it as NLX method, right? Right. By using this method, in this way only we need to write the electronic configurations by following some rules. What are the rules, right? So first one I am writing here, off bow principle, okay? What is mean by off bow principle, right? So the lowest energy orbitals, as we know what, in first orbit some electron, orbital is there, in second orbit also orbitals are there, in third also orbitals are there again. So like that, how many orbitals if you take, so that many number of orbitals will be there, right? So the orbitals, how they are filling, that is from lowest energy orbitals, that is lowest energy orbitals should be filled first. Lowest energy orbital should be filled first. Then how to know which is the lowest and which is the highest energy orbital, right? So for that we are having a diagram. Right? So that diagram we called as Euler diagram. What I am saying it is Euler diagram, okay? Right, I'll draw in a simple way, that is Euler diagram, right? So I'm drawing here 1s, 2s, 3s, 4s, 5s, 6s, 7s. Again we'll write here 2p, 3p, 4p, 5p, 6p. Again we'll write here 3d, 4d, 5d. Again here write here 4f, okay? And how to fill that, right? So let us say how to fill that. First orbit is there, no, right? The electron is filling in the first one directly, and the arrow mark is showing the entry of the electron. Arrow mark is showing the entry of the electron, right? Again the electron will go into the 2s. Electron will go to the 2s. Again you don't write like it is coming to back side, you write from top only, right? Then again 2p to 3s, then 3p to 4s, then again like this, okay? It will be like this. Now we need to write the energy series of these orbitals. This diagram we call as Euler diagram. Now I will write the energy series for this. All right, energy series. See it carefully, children. First electron enters into 1s, no? It is 1s, right? Lower energy, no? So 1s. The next electron enters into 2s. The next electron enters into 2p. Don't say it as 3s. Go to top again. 2p. Next coming to 3s. Again go to here. 3p. Next coming to 4s. So with I'm not having enough space, so I'm writing here 4s. Then next 3d. the next 4p, 5s, so on like this. So it is filling like this. So in this way, that is the arrangement of the orbitals. That is the arrangement from lower energy to higher energy. The orbitals are arranged like this. In this manner only we need to fill the orbitals. In that manner only we need to fill the orbitals, right? So first 1s should be filled, then 2s, then 2p, 3s, 3p, 4s, 3d. Then you will get doubt here. Here writing, what we are writing here, 4s we are writing, and here 3d we are writing, no? That is 4s means 4 is there, 3s means 3s is there, that is 3 is smaller than the 4, no? Then why we are writing the 4s? Means here one rule is there, that rule we are writing like n plus l rule. What we are saying it as n plus l rule, right? According to the n plus l rule, if you are taking the 4s and 3d, if you are taking the 4s and 3d, here write n and l values, n and l values will write here. In 4s, what is the n value according to NLX method? NLX method, right? NL 4s, that is n is the 4, l is the, s means what? In the azimuthal quantum number we discussed, no? 0, 1, 2, 3, s, p, d, f we discussed, no? Right? So that is l value will be 0, so it will be 4 only. When we take in the n plus l, it will be 4. Now coming to 3d, n value will be 3, l value will be 2, then it will be 5. Who is bigger than, who is higher here? So obviously 3d is the higher, so 4s is filling first, right? So that is, we are filling the electrons as per Aufbau principle. That is, Aufbau principle means what? Lower energy orbitals are filling first, then it is going to higher energy orbitals. Okay, that is a one rule. In this one rule you need to write, so two cases, you need to learn the two cases, like Euler diagram you need to learn, and you need to learn the n plus l rule also, right? And then next one I am writing here Hunds rule. I am writing here Hunds rule, we can call it as Hunds rule also, right? So what is mean by Hunds rule? Means in a s orbital, how many suborbitals are there? Only one suborbital, right? In p orbitals, 3 suborbitals are there. In d, 5 suborbitals are there, right? So if the p is having the suborbitals that we wrote like what? -1, 0, +1 we wrote in the magnetic quantum number, or that you can mention like px, py and pz also you can mention like, right? So these orbitals are having the same energy. These orbitals are having the same energy, that we can call it as degenerate orbitals. Degenerate orbital, that means orbitals which are having the same energy, which belongs to same orbitals, are called as degenerate orbitals, right? Coming to the Hund's rule, the degenerate orbitals should be filled first with 1 electron each. The degenerate orbitals should be filled first with 1 electron each, then the pairing should be starts. Pairing should be starts after degenerate orbitals are filled with each 1 electron. Okay, so that is Hund's rule. Hund's rule. So how that is we will discuss here, right? Suppose we'll take carbon. We'll take carbon. We'll take, so carbon number is what? 6. Carbon number is 6. So we can write the configuration as per Aufbau principle, right? And we know what? In each suborbital there is only 2 electrons will be there. So according to that, s orbital can hold 2 electrons. S orbital can hold 2 electrons. P can hold 6 electrons. D can hold 10 electrons, and F 14 electrons they can hold. Yes or no? Right. So here we are writing the carbon configuration, that is 1s2, 2s2, 2p2, 1s2, 2s2, 2p2. Okay, right. So see this, we can mention like this. In s orbital 2 electrons are there, only one suborbital is there, 2 electrons. Again in 2s, s orbital 1 suborbital is there, 2 electrons. Again in 2p, 3 suborbitals are there, no? In the 3 suborbitals, these 2 electrons should be given to degenerate orbitals. It should not be filled like this. They should not be filled like this. Okay, so we need to write like this. Okay, that is the pairing should start after filling the degenerate orbital. That means if suppose nitrogen you take, one electron comes to here, if suppose oxygen you will take, one electron comes to here, next electron comes to the pairing. But we need to do what? First we need to fill the degenerate orbitals with one electron each, then only pairing should be starts. Okay, so that is Hund's rule. Right? And next one, Pauli's exclusion rule. Pauli's exclusion rule. What is mean by Pauli's exclusion rule? Right? So let us say no two electrons of same atom, no two electrons of same atom having the four quantum numbers same, that is, if you take any atom, any one atom, if you taking, in that one atom no two electrons are having the same four quantum numbers. That means in an atom all the electrons are having the different quantum numbers. That means at least one quantum number should be different. Suppose we will take a example, helium we will take. Suppose, as we know, helium configuration 1s2, two electrons are there, right? So the two electrons will be, one is in a clockwise, one is in anti-clockwise direction, right? Now let us write here, two electrons are there, no? In 1s2 two electrons are there, right? That is 1s, one electron is there, 1s, two electron is there. If you write the all the quantum numbers for these two electrons, right? N, L, M and S. Okay, here also N, L, M and S we will write for that. Okay, right. How it will be now? According to NLX method, here 1s1 is there, N value is what? 1, S value is what? S means 0. If L value is 0, M value will be 1. That we can also mention with a 0. Why? Because we need to write one quantity, 0. S means what? Spin. First electron is in a clockwise direction. If you are showing the upward arrow mark, that is clockwise direction, and that is plus half. Okay, coming to second electron, one s2 is there, N means 1, again here 0, M value also 0, S value, second electron is the second electron, anti-clockwise means minus half, right? So these are the rules we need to follow while writing the electronic configurations. You see this here, in this, two electrons are there in the helium, two electrons are there in the helium. Quantum numbers are, three of the quantum numbers are similar, but the fourth quantum number is different. That is, no two electrons of the same atom is having the four quantum numbers same. That means 4 cannot be same, 3 can be same, but 1 is different, no? So that is the thing, Pauli's exclusion principle or Pauli's exclusion rule, right? So these are the rules we should follow while writing the electronic configurations. Okay, so that is Aufbau principle. That is, what is my Aufbau principle? Lowest energy orbital should be filled first, right? And in that we are writing the Euler diagram and N plus L rule. And next Hund's rule. Hund's rule means what? The degenerate orbitals should be filled first with one electron each, then the pairing should be start. Then Pauli's exclusion rule is what? No two electrons of the same atom having the four quantum numbers same. That is Pauli's exclusion rule, right? So by using these rules and in the method of NLX method, we are writing the electronic configurations of the electrons. Okay, right.